to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. So without further ado, here is Ms. Yvette Chuca and Mr. Ruben Carizales.
Hello, everyone. Ms. Salazar just put the link in the chat for those that need to go to 1324. And at any time, if you can't hear me or something, just let me know in the chat. And if I happen to drop off the call, just be patient. I'll log in right away. So today, what we're going to be looking at is inverses and determinants. And so in chapter 7, when we were looking at systems of equations, we learned different ways of solving a system. For example, you could use the elimination method, you could use the substitution method, or you could use graphing. And then in section 8.1 from this week, you're learning how to use the Gauss-Jordan elimination to solve a system. And so last week we did some examples on that. So today, inverses of a matrix and determinants are also another way to use to solve a system. And so we'll be looking at some examples of that. Okay, so first, what is the definition of an inverse? And so basically, the inverse, the symbol that you use for inverse is the superscript of -1. The -1, if you see that, represents that it's the inverse. And so here's your -1 there. Now, anytime that you multiply A inverse times A, if it gives you what we call the identity matrix, and if you reverse it and multiply A times A inverse, and you also get the identity matrix, then we say that this is going to be the inverse. And just remember that the identity matrix are matrices that have 1 in the diagonal and 0 everywhere else. And so this is the 2x2 identity matrix. And then the 3x3, if you notice here, it has all ones and everything else is 0. So again, in order to determine if something is an inverse of each other, you should be able to multiply the matrix A times its inverse, and it should give you the identity matrix. But more importantly, you should also be able to reverse these, and you should still get the identity matrix. Okay, so let's look at an example. And so this, I forgot to mention that section 8.3 and 8.4, most of you will be looking at those sections starting next week. And some of you might have already started to look at those. And so this will be kind of getting you ready for what's going to be due next week. So here it says show that B is an inverse of the matrix A. Okay. So in order to show that they're inverses, we need to be able to multiply the two matrices together, and they should be able to give us the identity matrix. And if that happens, then we can say that they're inverses of each other. So first, we're going to multiply A times B. And so we take the first row. So this is my first row here. And we're going to multiply it times the first column. We can see that this is a 2x2, and this is a 2x2. So these inside numbers are the same. That way, that tells us that we can multiply them. So we're going to take -1 times -1, and then 2 times 1, and then we add those results. And so we're going to have -1 plus 2, and so that's going to give us a, well, we'll reduce it right now, but that's going to give us a 1. So then you still keep that same row, but now you go to the second column. So we have -1 times a -2 is a +2, and 2 times -1 is a -2. And so for that one, we get 2 minus 2. So we'll reduce that in a little bit. We don't have any more columns, so we're going to go to the next row. So now we're going to have a -1, +1, gives me a -1. And then the ones in green, 1 times 1 is a +1. And so we're going to get -1 plus 1, which is going to be 0. And then the next one is -1 times the next column. So -1 times -2 is a +2, and 1 times -1 is a -1. So if we simplify, -1 plus 2 is a 1, and -2 minus 2 is going to be a 0, and -1 plus 1 is 0, and 2 minus 1 is 1. Okay, so as you can see, this is the identity matrix, so that's a good thing. Put a check mark here. But now we also have to check if we reverse these, if we multiply B times A, then we need this to be in the identity matrix as well. So let's see if we get that. And so again, to multiply this, we just follow the multiplication. So we would have this row times this column is going to give me this right here. And then we go to the next row. So the same row times the same column will give us this. And then we're going to do the last row by the first column will give us this information. And then the last row by the last column will give us this last number here. And so if we simplify, you can see that we also end up with the identity matrix. So since we got the identity matrix for both of these, then we're going to be able to say that they are inverses of each other. Okay, so we say B is the inverse of A. Any questions on determining if something is the inverse of each other? Okay. So for the next part of the session here, we want to make sure that we're able to find the inverse. And so there's different ways to find the inverse. And you can use any method except this method here. Let me circle it. This method here, right here, is only good if for any 2 by 2 matrices. Other than that, we cannot use them. Okay, so the other methods work for any size of a matrix. Now, not all matrices have inverses. That in a few minutes. And so if we look at the left side, it says write the matrix on the left side and identify and the identity on the right side. So this is the first method that we're going to look at. And so it's asking us to write the matrix, and then we're going to attach an identity matrix. And then we're going to use row operations so that when we use the row operations, we want to end up with the identity first. And whatever's on the right side is going to be our inverse. Another way to solve is to look at AX is equal to I. And X is basically going to be your variables here, which you'll see here in a second. And then, of course, we have this one, which is it's an easier method if you have a 2 by 2. So let's go ahead and try the AX equals I method first. So it says find the inverse of A. So what we're going to do to do this is we're going to write our matrix. We're going to have our A, which is what the problem is. And then we're going to attach this X matrix. And the X matrix is going to be made up of, we're going to call these X11, X12, X21, X22, where the subscripts are only identifying the location of a number. So for example, the X11, that means that that's the first row, first column. And then on the right side is going to be your identity matrix. Okay. So what we're going to do is we're going to multiply the A times the X matrix. And so we're going to go ahead and multiply these two together. And so when we do that, then we're going to end up with, and let me just do the first ones, that way we can see what we get here. So if you take this first row times this first column, then we have 1 times x11, and so that's this number here, x11. And then we have 4 times x21, and that's the second number here. And then we're going to go to this next column. So we would have 1 times x12 is x12, and 4 times x22 is 4x22. So then after that, we don't have any more rows. So we're going to go to the next row. So I'm going to go to this second row, and I'm going to use the first column again. Okay, so we're going to have -1 times x11. So that gives you a negative x11. -3 times x21 is a negative 3x21. And then we go to the second column. So we have -1 times x12. And -3 times x22 is going to be negative 3x22. Okay, so once we have it multiplied, then we're going to set up a system. And so the system that we set up is going to be, so we're going to take our x11 plus 4x21, and we're going to set it equal to the 1 that's here. So that's where I get this first equation. And then we're going to take the next number here, -x11 minus 3x21, and we're going to set it equal to 0. So that's going to be this system here. And then the next system is going to be the next column, which is x12 plus 4x12, and we set it equal to 0. And then the last number here is -x12 minus 3x22, and we're going to set it equal to 1. Okay, so what we created here is a system. Well, now with the system, we can solve using any method we want. And so if you notice here, my system, I can choose to get rid of the variable. And if you notice x11, and I have a negative x11, so I'm going to choose to get rid of those, since I can just add them and they'll give me a 0. And then for this one, I can do the x112 and the negative x112. So I'm going to go ahead and eliminate those. So I add these, this becomes 0, and then 4x21 plus a negative 3x21 is going to give me a x21 here. And then 1 plus 0 is 1. So I have solved for x21. And then we'll do the same on the, we're going to go ahead and back substitute so that we can find our next number. And so if I plug in my x21 that I just found, so here I found x21 is 1. So I'm going to use the first equation, x11 plus 4. And instead of x21, I'm going to substitute the 1. And so I get a 4. And I'm going to subtract the 4 on both sides. So I end up with x11 is equal to -3. And then I go ahead and do the other system. If I add the two equations, then I get 0. And 4x2 plus 3x2 is going to give me an x22. And 0 plus 1 is going to be 1. So we're going to back substitute that number back into the equation. And so I'm going to go ahead and use equation number 1. So I get x112 plus 4 times, instead of x22, I'm going to go ahead and to the 1 and then solve for x. So we're going to subtract by 4, and we end up with x12 is equal to -4. So here we have all of our numbers. X21 is 1, x11 is -3, x22 is 1, and then we have a -4. So again, remember, these are the locations. So this is the second row, first column. This is the first row, first column, and so on. So if we put it into a matrix, then we end up with x11 is -3. So that's going to be, let me get the pen here. So this number here is going to be in our first position, because that's the first row, second column. And then we have the first row, second column. So that's going to give -4 here. And then we have the 1 and the 1. Okay. So our result here, this is going to be our inverse. Okay. Now this method seems very long, but if you are one of those people who like to solve systems using elimination or substitution, then this would be the way to go. Okay. So let me go ahead and show you the other method. The other method is to attach the identity matrix. And so if you notice here, I have my matrix A, and then I'm attaching this identity matrix here. So I'm going to use row operations so that when I'm done, what I want to have is my identity matrix on the left side. So I'm going to want it to be written like this. And then I'm going to have these numbers over here. I'm just going to call them A, B, C, and D. And when I get to this goal here, then this right part is going to be your inverse. Okay. And so this is using the row operations that are from section 8.1. And so I'm going to walk you through those here. So again, your your goal, let me write your goal up here so that we can keep seeing it. So this is going to be 1, 0, 0, 1. And then we're going to have other stuff here. So I'll just put that. So your goal is to have a 1 here. And so if you notice, we already have a 1, so that's great. We don't have to do anything. So we're going to next want to make this 0, or we want to make sure that this 0 is a 0. In our example, instead of 0, we have a -1. So in order to make that a 0, what we're going to do is we're going to add row 1 plus row 2. And then our answer, we're going to 2. So we're not going to change row 1. Row 1, if you notice, it stayed the same. So let me go ahead and underline row 1 here. You can see that those numbers did not change at all. But now if I add row 1 plus row 2, so if I take 1 plus -1, then I get the 0. 4 plus -3 gives me this 1. 1 plus 0 gives me a 1. And 0 plus 1 gives me a 1. And so that's great. So we have our 1 and our 0. And so our next part of our goal is we had a 1 here, and now we have a 0 here. So now we want to have a 1 here and a 0 on the top. And then whatever we get over here will be our answer. Okay. So you should focus next on making whatever number is here a 1. So in our example, notice that we already have a 1. So we don't have to do anything there because that's already a 1. So then our next goal is to make the top number is 0. And so for us, we have a 4. So we want to get rid of this 4. In order to get rid of that 4, we're going to multiply. So if you look over here at this information, you want to multiply -4 to the second row, and then you're going to add it to the first row, and whatever answer you get, you're going to put it back in row 1. So we're not going to change row 2. Row 2 is going to stay the same, and so you can see it here. Let me underline it so we can see it. So row 2 did not change at all. And now we're going to take our -4 and we're multiplying it times 0. So -4 times 0 is 0. And then I'm going to add it to this one here. Okay. And so when we do that, then -4 times 0 is 0 plus 1 is 1. So we don't change that number. So I just write my 1 here. And then we have -4 times 1 plus the 4 is going to be a 0. And so notice that I have my 0 here. And then I keep going. -4 times this one is -4 plus a +1 gives me a -3. So I wrote my number here. And then -4 times this one is -4. And if we add it to the 0, then we get a -4. Okay. So now you can see that we have met our goal. We have the identity matrix on the left side here. This is our identity. So whatever side, that's going to be our inverse. So we write a to the power of -1. -1 is the symbol for the inverse. And then this is going to be our inverse. Okay. So if you like using row operations, then that would be the method that you would use. Okay. Now the third method is probably some people's favorite. The third method is going to be using this formula. Okay. And so the formula tells you if you have a matrix and you have A is equal to A, B, and C, D, then what the formula tells us to do is to go ahead and write, give me a second here, is to go ahead and write A inverse is equal to 1 divided by A times D minus B times C. Okay, so we are cross multiplying. You could kind of think of it as that. So we're going to be multiplying A times D right here, and then we're going to multiply B times C, and then we subtract that information. Okay, and so the next thing that it asks us to do is to switch A and D. So instead of A being in the first row, first column, we're going to switch it with D, and then we're going to switch the signs for B and C. So instead of a positive B, now we have a negative B. Instead of a positive C, we have a negative C. If you start off with a negative number, then you would switch the sign. So you would end up with a positive number. Okay. So let's do this example here. So this bottom part, AD minus BC, is actually called the determinant, which is what we'll be looking at in a little bit. Okay. So here, my solution, went ahead and labeled these A, B, C, and D. So you can see the formula right next to it. So we're going to multiply A times D. So A is 1 and D is -3 minus B. B is 4 and C is -1. Then we're switching A and D. So A and D is now switched. So here's my D. This is my D. So I'm going to switch it and put it up here. And then my my A was the 1. And so now notice that we went ahead and switched the A with the D. Okay, so here's my A and here's. So now for the next part, if we have a +4, then notice I wrote a -4. And then I had a -1, so I switched the sign. So I have a +1. Okay, so now we're going to do this algebra here. So 1 times -3 is -3, and -4 times -1 is +4. We're going to go ahead and add -3 and -4. So that gives me a 1. So here we get a 1. And 1 divided by 1 is just 1. And then 1 times each of these numbers is going to be themselves. So if you had a number 2, you would have to multiply it times each element. And so this is going to be our inverse. So notice that you got the inverse for all 3 methods was the same. Okay. So let me show you one more way to do these, because depending on your instructor, you might be able to use your calculator. And so I just want to show you really quick how to do that. So I'm going to share my screen really quick. Let's see. Can you guys see my screen? I didn't see it go through. Oh, there we go. All right. So if you have a graphing calculator, can you guys see my graphing calculator? Or does it look distorted? We see it. Okay, great. So if you have a graphing calculator, you want to go to second matrix, and then you're going to edit and pick any of the matrices there. We had a 2 by 2, so I'm going to enter 2 by 2. I don't remember the numbers, so I'm just going to make up matrix really quick. So 3, 5, 9, and 1. So you put in your numbers, then you're going to second quit, and then you're going to call it back. So second matrix. And now you want to use it. So you're going to use A. And then you just use the inverse sign here, which is where the second matrix is. So I press it and then press enter. And if you notice, it has a bunch of decimals here. So what you can do is, let me see where it is. You can change it to fractions. I can find my key. I think it's under math. So fractions. And so then this, right? So your inverse. And so the other thing you can do with the matrices there is if you need to multiply, you just column. So let's say I have A and I want to multiply times another matrix. I don't have another one, so I'm just going to use A again. And then you would press enter. Okay. And then one more thing, if you want to do a Gauss-Jordan elimination, then this will also do it for you. Let me enter some numbers here. And okay, so if you want to use Gauss-Jordan elimination, then you press second matrix, you go to math, and then you're going to scroll all the way down till you get to RREF, which just means reduce echelon form. Call your matrix. So I use the A, and then you press enter. And so if you notice here, you have your 1, 0, 0, 1. Again, if you rather have a fraction, then you can put it in a fraction. And so that would be your answer there. Okay. Now, if you don't have a calculator, then it's not a problem. You can, let me go to a different page here. You can go to decimals.com. Just let me know if you can see my webpage here. But you can put matrix, just put decimals matrices calculator, and it's going to open up a calculator for you. So you put new matrix, enter your numbers. Let's say 4 and 3, 1 and 6 or 5. And then you can also do your row instructions here. Let me press enter here. Okay, so then I can say I'm going to use A inverse. Oops. Let me just go back here. I can press A and then press the inverse sign, and then you can see your answer on the right side. Okay. You can still do the RREF as well. So you can use those. Just be careful, because if you don't have, if you're not allowed to use a calculator, then you might need to know how to use those methods that we're looking at. Okay. So let me go back to the PowerPoint. Let me find it here. And let me get to we're on. And I'm almost there. Okay, so we used the formula. Okay, we're gonna be left off here. All right, so let's go back to using our paper and pencil. So it says use any method. So I'm gonna go ahead and use the formula. Okay. So is there any questions before we continue? Okay, so let's use the formula. So I write down the formula, and then we're going to go ahead and substitute the numbers. So here we have A is 3. So here's my A. And then D is 2. So I multiply those. 3 times 2. And then B is -1 and C is -2. So I'm going to multiply those here. I'm going to switch A and D. So I'm going to have a 2 and a 3. And then for B and C, notice that you had a -1 and a -2. So we change the signs to +1 and +2. If we simplify, we get 3 times 2 is 6, minus -1 times -2 is a +2. 6 minus 2 is a 4. So we end up with 1/4 times the matrix 2, 1, 2, 3. We're going to multiply by 1/4 into the parentheses or into the matrices. So 2 times 1/4 is 2/4. 1 times a fourth is a fourth. 2 times a fourth is 2/4. And 3 times a fourth is 3/4. Reduce your fractions, so 2/4 is the same as a half. And then we have the 1/4, the half, and the 3/4. So that would be our inverse. Okay, so then the next one, we have B is A inverse of, we're going to use the formula again. So we have 3 times 2 is 6, and -1 times -6. And then we switch the A and the D and switch the signs for 1 and 6. So if we do the work here, we get 6 minus 6 is 0, but notice here that we cannot divide 1 divided by 0. So whenever you have a 0 in the determinant, then we say that A is not invertible. So in other words, it doesn't have an inverse. So then we can stop there. Okay. So find the inverse of 3 by 3. So usually in my classes, for my students, giving them a test in class, they would have to show me their work for the 2 by 2s. But like for something bigger, like a 3 by 3 or something bigger, then I allow them to use the calculator for that. So one way you can do that, again, is you can use a calculator if your instructor allows you to do that. You can use any method you want. I'm going to go ahead and use the AX equals I method. And so again, x11, x12, x13, those are all just positions of numbers, okay? But since we don't know the numbers, then we're just calling them x11 and so on. And so we're going to do the same thing we did earlier. We're going to multiply this row by this column. And then we're going to multiply it times this column. And then times this column. Okay. And what we do is we take the 1 and we multiply it times the first number. Then we take the second number and multiply it times the second number. And then we take the third number and multiply it times the third number. And then we do the same with the second row and the third number there. Once we're done with that, then we go to the second row and we start the process again. So we go with the first column, second column, third column, and then we do the same thing with the last row. We take this row times the first column, and then the next column, and then the next column. Okay, so what I'm going to show you next is going to be that work. And so it looks crazy, but if you like solving using elimination or substitution, then this is the way to go. Otherwise, you can attach the identity matrix and use row operations, or you can use the calculator, okay? So 1 times x11 gave me this x11 here. -1 times x21 gave me the -2x1. And then 0 times x31 is 0. And that's why I don't have anything here, okay? So I did all of that work. And so I will let you maybe come back later to look at each of these, okay? So here's just multiplying the two matrices. What we do then is we take those results and we write systems. And so the first system is coming from x11, x21, and I'm going to set it equal to that first number over here. So equal to 1. Then I take the next one, x11, x31, and I'm going to set it equal to 0. And then we go to the next one, this third one, and then I'm going to set it equal to 0 as well. And then I do the second row is x12, x minus 22, and we're going to set it equal to 0. And then we take the second one, set it equal to 1, and then the third one, set it equal to 0. And then we do the same for the last one, x1323, set it equal to 0. And then we have the 0 and the 1. So we have 3 different systems. And then we're going to go ahead and eliminate the variables. So for example, in the green one here, I can get rid of this x11, okay? And then over here, I can get rid of the x12s and so on, and then back substitute, okay? So it's kind of long here, but it's going to be, you'll see that it's just using the elimination method. So what I did here is I took the first 2 equations, and I want to get rid of x11. So I multiply by -1 to the first equation. So this times this gives me x11, and then negative times negative gives me a positive, and -1 times 1 gives me a -1. So if I add them, this is going to be 0. Yes, ma'am. There's a question? Okay. So I get 0 here, and then I end up with x21 minus x31, and -1 plus 0 is -1. So next, I need to still get rid of this x11. So remember from chapter 7, we can use one of the equations in the third equation to get rid of the same variable. So I'm going to multiply by -6 to the first one. So I get 6 x1 right here. And then -6 times negative is a positive, and -6 times 1 is a -6. And remember, this is your third equation that was here already. So if you add this, we get a 0. And then here we get 6 minus 2 is the 4x21. And then we get our -3x31. And 0 plus -6 is -6. So remember in the chapter 7, you created 2 equations, number 4 and number 5. So you're going to take those 2 equations, and we're going to eliminate one of the variables. And so we'll eliminate, in this case, we can get rid of the x21. So I'm going to multiply by 4 into this equation. So I get -4x21, and then negative is -4 times -1 is a +4. And then I have my other equation. So when I add, I get 0, and then 4 plus a -3 gives me a 1. And then 4 plus a -6 gives me a -2. So I finally found one of the variables. And so to get our answer back, we're going to back substitute. In other words, we're going to need to take this answer and plug it back in to this equation here or to this equation here. And then that's going to give us the x31. I mean the x21. Okay, so I did that already here. Let me just use the marker so you can see where I'm going to be pointing to. So I took the first equation, x1 minus x31, and we're going to substitute a -2 right here. And so then if I negative is a +2, subtract it on both sides, so we end up with -2. So now we know x11, and then we're going to substitute the next one. So x21 minus x31, we know what x31 is. And so that gives us x21 is -3. So so then we're going to end up with our first column is done. And so I'm going to go just really quick through the next ones because this might not be the best method for everybody. But the idea is that we can use the elimination method to help us solve for the inverse as one of the methods. Otherwise, you can use the identity matrix or the calculator. So notice here we got this first column. So all of that work was for that column. But then remember we had 3 different systems. Oh, it didn't come out. So then we would do the same thing. Let me just go back really quick. So remember here we had the blue and the purple. So we would follow the same process and to find the second column and the third column. So if we continue the process, then this would be our inverse here. So you might be wondering like, well, what is the inverse for anyways, right? So the inverse is going to help us to solve the system, which is what we're going to do next. Just here really quick, this is the other method that I was saying. You can attach the identity matrix, and then you can use the row operations so that your identity matrix is on the left side, and then this would be your inverse, okay? So that's the second way to do it. So why do we want the inverse? Let me go back. We want the inverse so that we're able to solve a system. And the way we're going to solve a system is using this formula here, okay? And we're going to take the inverse times b, and that's going to give us our answer for x and y, or in sometimes c. So I'll tell you what the b and the x and all that mean here in a second. So it says use the inverse matrix to solve the system of linear equations. So we have a system here, and they tell us that this matrix is already your inverse, okay? So this here is already A, or it's already the inverse, so I'm just going to call it A inverse. Okay, so A is 1, 3, -3, and 8. B is made up of your constants. So B is always going to be your constants. Okay, so these are my constants, and that's matrix B. And then you're going to need a matrix X. X is made up of your variables. And since we only have 2, they are X and Y. So whenever you do this, you're going to need to find A inverse first. Okay. But this problem already gives it to us. They tell us what the inverse is. So we don't have to do the work because they already give it to us. Here is our inverse. Let me go ahead and circle it again. So remember this guy here. That's our inverse. Okay, so to solve the system, we're going to write the inverse. So I wrote the inverse here. And then we're going to write our constants, which is 4 and 12. And then we're going to multiply the matrices together. So to multiply, remember we take the row. So we take this row times this column. So -8 times 4 is -32. And then 3 times 12 is 36. So -32 plus 36 gives us that 4. And then we go with the second row. -3 times 4 is -12. 1 times 12 is 12, so we get 0. So from here, we can say that x is equal to 4 and y is equal to 0. Okay, so that is one way that we can solve this system. So x is equal to 4 and y is equal to 0. Again, the other ways are from chapter 7, which we already looked at. Okay, so the idea here is we need to find this inverse first and then multiply times the constants. And some problems, they give you the inverse already. So like here, they don't give me the inverse. So the first thing you want to do is write down your matrices that you have. So in this case, my A is made up of all my coefficients. So that's the 1 in front of the x, the -5, the 5, and the -24. And then B is my constants. And then x is going to be my variables. Okay. So the first step is we need to know what A inverse is. So I'm choosing to use the formula. So I have 1 divided by A, which is 1, times D, which is -24, minus B, which is -5, times C, which is 5. I'm going to switch my A and the D, and I'm going to change the signs for B and C. Okay, so we simplify. We get negative 24 minus negative 25. Simplify some more. So we get 1 divided by 1. And so our inverse is going to be 24, negative 24, 5, negative 5, and 1. So this is our inverse. Okay, so it seems like we finished the work already. But remember, we're not trying to find the inverse. We did find it because we need it. But our answer is going to be once we multiply. So we take our inverse times the b. So we're going to multiply negative 24 times 27 and 5 times 128. And so that's going to be negative 24 times 27 plus 5 times 128 and negative 5 times 27 and 1 times 128. And so we get these big numbers, right? But when we subtract, simplify, we get that x is equal to negative 8 and y is equal to negative 7. Okay. So last one here, use the inverse matrix to solve the system. So they already gave you the inverse. So all you need is your constants, which are 0, 6, and 3. So we're going to multiply it, right? So here's my inverse times the constants. So we multiply this row times this column. So we have 1 times 0 is 0, 1 times 6 is 6, and negative 1 times 3 is negative 3. And so 6 plus negative 3 gives me this 3. Then we go to the second row. Negative 3 times 0 is 0. 2 times 6 is 12. And negative 1 times 3 is negative 3. So if we add negative 3 and 12, we get 9. And then the last one, 3 times 0 is 0. Negative 3 times 6 is negative 18 plus 6. So we end up with negative 12. So my solution is going to be, x is equal to 3, y is equal to 9, and z is equal to negative 12. Okay. So for section 8.4, we have 13 minutes. So the determinant, as I mentioned before, when you're doing the inverse, it's the AD times the BC. Okay, so the determinant of A, we represent the symbol for determinant as the absolute sign, like the little vertical straight lines. That's a symbol for determinant, or you might see it written like this. Okay, but either way, we're going to multiply A times D. In this case, A1 times B2. And then we're going to multiply A2 and B1. And whatever we get, we're subtracting them. And then that's going to be your determinant. Okay, so if we look at letter A, you're going to multiply 2 times 2. And then subtract negative 3 times 1. And so we get 2 times 2 is 4. And then negative 1 times negative 3 is positive 3. So we end up with 7 as our determinant. And then for the next one, letter B, we're going to multiply 2 times 2 and 4 times 1. So we end up with 2 times 2 minus 4. And 2 times 2 is 4. Minus 4 is going to be 0. So my determinant is 0. And then letter C, we're going to have 0 times 4 minus 2 times 3 halves. 0 times 4 is 0. And 2 times 3 halves is 3. So we end up with 0 minus 3 equals negative 3. Okay, so that's going to be for 2 by 2s. For 3 by 3s, we'll use this slide in a little bit. The way we find the determinant for this is, one, you can use a calculator. But if you want to do it by hand, then what we're going to do is we're going to take the first row and the first column. And I'm going to circle that first number there, which in this case is 0. But you can focus on canceling, or not canceling, but what's the word? Well, scratching out the first row and the first column. And if you notice, it kind of leaves you with a 2 by 2 after you do that. So let me circle that here. Okay, so it kind of leaves you with this 2 by 2. So we're going to call this M11, where 1 and 1 represents the first column and the first row, that's the 0 that I circled. And that's going to be equal to the determinant of this thing that I highlighted in red. So we multiply -1 times 1 and 2 times 0, so that gives us a -1. So then we go ahead and we still have that first row scratched out, but now we're going to scratch the second column. And so if you notice, it still leaves you with 4 numbers. So these 4 numbers are the 3, the 2, the 4, and the 1. So we can take the determinant of that. So we would say 3 times 1 and 4 times 2. So 3 minus 8 is going to be -5. Okay. And then we keep going on. So the next one is we're going to cross out that third column, leaving us with these 4 digits here, 3, -1, 4, and 0. So we find the determinant there. So 3 times 0 is 0. 4 times 1 is -4. So we end up with 4. So now we've finished with all the first row and the columns. So now we go on to the second row. So if you notice here, I crossed out the second row. So I crossed out the second row, and I'm crossing out this first row. So I'm left with 2, 1, 0, 1. So the determinant for that is a 2. So now we do the second column, right? We cross out the second column, second row. And every time we're leaving 4 numbers. And these 4 numbers, we take the determinant. 0 times 1 is 0. 4 times 1 is 4. And we end up with -4. And then the third column. So we keep doing this until we're finished. And we're going to end up with these 9 numbers here. Okay. So let me get my pencil. So the last one you would do is going to give you these numbers on the right side. So once you have these numbers here, then we're going to look at the cofactors. And those cofactors are going to be, give me a second. I changed the slide, but it's just going, okay, there we go. So these cofactors here, if you notice, here's my cofactors. And so what we're going to take is our determinants that we just found, and we're going to make sure that we apply these signs here. So I'm going to take my first number, -1, and I have a positive. So -1 times a positive number is still going to be negative. And then I have a -5, and a negative is going to be a positive. And so what we're going to end up with is -1 times a positive is negative, and -5 times a negative is a +5. And we keep going. So 4 times a positive is 4, and 2 times a negative is -2. -4 times a positive is -4, and so on. So now we're left with these numbers, and that's going to be your, the determinant is going to be the sum of the entries in any row. You can pick any row or any column and take the sum of it, and that's going to be your determinant. So for example here, if I choose, this is one of them here. Oops. So if I take this row here, I'm going to end up with 14. If I use the other one, I'm still going to end up with 14. And if I use the other one, I'm going to end up with 14. So once you do these, then you can, you're going to end up with this with the same number at the end. Okay. So why do we use determinants? So yet again, we have another way of, I have 6 minutes, so I might have to go really quick on this, but using determinants is another way to solve a system, okay? And the way you're going to solve a system is you're going to take your matrix, which is the coefficient matrix here, and you're going to find the determinant of that matrix. And so again, that would be A1 times B2 and then B1 times A2. Then we're going to create another matrix here, DX. And instead of A1 and A2, we're going to replace A1 and A2 by the constants, okay? And then for dy, we're going to replace the y's with the constants as well. So to get your solution, you're going to take the dx divided by the d. So it's going to be this determinant and then this determinant. So let me give you that example. So here's my system, and I want to solve using determinants. So first, we need to know what these matrices are. And so we're going to write those here. So the first one, the coefficient matrix, is just going to be 4, -2, 3, and -5. So we're getting these coefficients. Okay, and then we're going to get the determinant of that. So 4 times -5 is -20, and then 3 times -2 is -6. If we add that, we get -14. Then we need dx. Okay, so dx, here's dx, right? So for dx, instead of writing the a, remember a was 4 and 3, we're going to replace that with the constants 10 and 11, and then we still keep the same coefficients for the y. So then we find that the determinant 10 times -5, 11 times -2, and we get -28. And then for dy, we're going to keep and we're going to replace the b with the constants. So instead of -2 and 5, we're writing 10 and 11 here. Find the determinant. And now our answer is just going to be x is equal to dx divided by d. So for dx, we got 28. For d, we got -14. So x is equal to 2. And then y is 14 divided by d, which is -14. And so we get y is equal to 1. So the determinant and the inverse are just other ways of solving these systems, okay? And so I know those last few slides were really quick, but if you have any questions, please feel free to stay here. There will be no happy hour next week because we'll have the Thanksgiving holiday. But after that week, we'll come back for our last happy hour session, which is going to be just a review for your final exams. And so thank you for joining us today. And I will pass it back over to Ms. Salazar or Ms. Truman, and have a great weekend.
Thank you, Ms. Chico, for your wonderful presentation. I'll be stopping the recording now, but we do want to remind you guys about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. Also linked is a short survey to help us improve our TVE sessions, so please take a few minutes to fill out that survey and to fill out another survey to receive credit for attending. Thank you all for coming in today. We hope you guys have a lovely weekend and a lovely break. Again, we will be coming back on December 3rd for our last TVE presentations, okay? If you guys have any questions, feel free to use the chat box or your mic. We hope that you guys have a lovely weekend.